I should be back. Alright, I should be back, guys. Sorry about that. Anyway. That's so frustrating. This, you need to do a quadrant check for if your eccentricity vector is below the IJ plane. Okay, it's that simple. So we need quadrant checks for 2 of these now. Number 5. So, we now have the following. We've got inclination, we've got eccentricity, semi-major axis, right ascension of the ascending node, and argument of periapsis. Number 1, number 2, number 3, number 4, and number 5. But here's the cool part, right? All are not dependent on time. Right? For the two-body problem. For two-body problem. So, we need, finally, some parameter that is a function of time to let us know where we are along the orbit, right? So if we've got an orbit, whoa, some orbit there. So we've got a planet, and then we've got an orbit, right? We've got a few things, right, that we can automatically see right on the screen. But let's say that this is your position vector right here, right? Clearly, you can be at several different position vectors, right? Multiple different position vectors. So we need a way to describe exactly where you are along the orbit, right? Where you are and in what direction you're going, right? Clearly, you know, by looking at this, you can tell that maybe an angle would be the best way to approach this, right? But what angle? From what direction? Like, how do I don't know. It's just a ton of questions. How do we get this, right? I have no idea. We need a way to define where we are along the orbit. That's, so I'm just gonna write, where are we along the orbit? We have no way of determining that quite yet, right? The answer to this question will have to wait until next time, because I need to go take care of my tires, and I've got other things to take care of. Anyway, we need to find an answer for this. Where are we along the orbit? There's one parameter that we're clearly missing that is dependent on time. So we need a time-dependent parameter. Okay? We need one, and we don't have one yet. That's gonna have to wait till next time, though. So, guys, I hope you enjoyed this. We've derived 5 out of the 6 elements that we need, and check it out. These elements are not dependent on time at all. It's that easy. They're not dependent on time at all, but we need some number 6 that we don't know yet. We need some number 6 that actually defines where we are along the orbit. But we've got 5, right? We've got a really good start. And we got all the way from here, right? Starting with just a position and a velocity vector for an orbit. Right, and with just a position and velocity, all 6 of those parameters, all 6 of those components are dependent on time. What did we set out to do, right? Remove time dependencies from most of these. We're assuming we're in a two-body problem. And we need 6 components that do have an easy visual, right? Because this has no visual. Like, what does that mean for an orbit? That means nothing. But slowly, through time, we started deriving what an orbit is. We started with inclination, what this value is, right? Clearly, inclination has a significance as to how tilted your orbit is. And then we went into eccentricity, which is how eccentric your orbit or elliptical your orbit is. I gave you this equation, and I basically said, don't worry about derivation. Don't worry about it. Don't worry about derivation. But we derived the eccentricity vector that's dependent on two vector components that you're adding together or subtracting to get us our eccentricity from our eccentricity vector. And that tells you how, wide or narrow our orbit is. And then we came up with semi-major axis. Hey, awesome, Callow. Callow, again, if you have any questions, let me know. I plan on producing a worksheet eventually so you guys can work out a few problems related to this. And again, the only benefit, and I wrote it up here, again, worksheet number 1 is coming out next Wednesday, okay? The only reward that you get for doing this worksheet is that I will spend in-depth time going over the problems that you write, correcting them for you, and leading you along the correct direction as to how to do these problems, okay? That's what you get from doing this worksheet that I'm going to put out, okay? You get to see what you did wrong. That's my reward for you. Anyway, then we've got semi-major axis, right? Semi-major axis is how large your orbit is, and we defined it as calculating values that we already have. We already have h, we already have mu, and we already have e at this point. We already have all of these values. So we can calculate semi-major axis. And then, for our fourth parameter, we wanted to define our rotation, or like our angle around the z-axis. We're rotating our orbit now along the z-axis. And we called that the right ascension of the ascending node. And then for our fifth one, we basically said, all right, now let's take our orbit and let's rotate it in plane, right? Let's rotate this thing in plane along the angular momentum vector. And that's going to be our argument of periapsis, because again, this is your periapsis vector, or your eccentricity vector. And now we're rotating it in plane to get our fifth one. For our sixth one, though, we unfortunately do need to have some dependency on time to define where we are, right? And we will go over that next time. But these are the first 5. We've got 5 down. We've nailed these 5 down. All right, and I'm gonna write these out for you, just to make it a little bit simpler. So we've got inclination. Are we tilted? Are we tilted at all? And then we solved eccentricity, right? How elongated or circular are we, right? That's the second one that we came up with. And you can see each of these defines like a visual parameter of the orbit. That's why it's so much easier to work in this mode rather than position and velocity. Then we solved semi-major axis. How large is the orbit? Right? And then we had right ascension of the ascending node. How are we rotated? How are we rotated along the up direction, right? And then we calculated little omega. Oh, please do, man. No problem. And you can also ask me questions on Discord, man. Feel free to get on that Discord and ask me questions. And then we've got little omega, which is how are we rotated along our orbital plane, or orbit plane, right? But then we need this sixth parameter that we don't know yet. And where are we? Where are we along the orbit? So, we've got these 5 that we defined like this. Number 1, number 2, number 3, number 4, and number 5. So hopefully, you guys may have already known some of these. Like maybe you already knew what these first 3 were, but you really didn't know what the 4th and 5th one were. But now you know, okay? So anyway, Whew, we've got 5. We'll derive the 6th one a little bit later. We made some good progress today, guys. We went over a lot of information, like a lot of information here. So it was all good. It was all good stuff, though, right? So we've got 5 now. We've got 5 of 6. Everybody, thanks for hanging out. It was a lot of fun. I'm going to go take care of a few things that I need to take care of. So, again, thanks for hanging out. It was a lot of fun. It was really cool. But I think I'm done, man. I am just about done here. So, everybody, thank you so much. Thank you so much for hanging out. I will see you next time. I'm going to log off. I'm going to go fill tires in my... Fill tires? I'm going to go put air in my tires. I don't even know how the heck to do it, but I'm going to look it up online. No idea how to do it. No, not necessarily, Mank. Everybody, have a great day. I hope you enjoyed lesson number 2 in AERO 101. If you have any questions, again, go over the notes and ask me the questions. I have Discord for a reason. Ask me the questions so everybody else can see your questions too. You're probably not the only one with questions, so ask them, okay? All right, everybody, have a good day.